Welcome. In this video, we'll learn about optical flow based tracking. Optical flow is a very popular technique used in computer vision. It uses image feature points to track an object. Individual feature points are tracked across successive frames in the live video. When we detect a set of feature points in a given frame, we compute the displacement vectors to keep track of it. We show the motion of these feature points between successive frames. So let's open my directory which contains the script. Let's open opticalflow.py. Let's run the script. If you run the code, you will see a window showing live video. You will see feature points. If you move around your hands, you will see the line showing the movement of those features. Just observe it. If you then move in the opposite direction, the line will also change their direction accordingly. Basically, we show motion of these feature points between successive frames. These vectors are known as motion vectors, and there are many different ways to perform optical flow. Now let's see the code behind it. So the first one is import CV2, which we know it. Next is import numpy as np, which we also know it. Now let's define a function to track the object, that is def start tracking. Now initialize the video capture object, that is cap equals to CV2 video capture 0. If you are using secondary camera, then keep it as 1. Now let's define the scaling factor for the frames, that is scaling factor equals to 0.5. Now let's define the number of frames to track, that is number of frames to track equals to 5. Now track and number of frames to skip, that is number of frames jump equals to 2. Now initialize variables related to tracking paths and frame index. So tracking path equals to empty square bracket frame index equals to 0. Now define the tracking parameters like the window size, maximum level, and the termination criteria. So defined tracking parameter like window size, maximum level, and termination criteria. Now iterate until the user hits the escape button and capture the current frame. While true, frame equals to cap.read. Now resize the frame here. Frame equals to cv2.resize frame none fx equal to scaling factor. Now convert the frame from RGB to grayscale, which we always do, so that tracking becomes easy. That is frame gray equals to BGR to gray. Now create a copy of the frame. Output image equals to frame.copy. Now check if the length of tracking path is greater than 0. If length tracking path greater than 0, previous image, current image, we are just reassigning with the gray frames. Now organize the feature points. Now compute the optical flow based on previous and current image by using feature points and tracking parameter. That is feature points equals to optical flow, previous image, current image, feature points, tracking parameters. Now compute reverse optical flow. This will compute the reverse optical flow. Now next compute the difference between forward and reverse optical flow. This will give the difference between forward and reverse optical flow. Now extract the good feature points. Good points equals to different feature points. Now initialize the variable for the new tracking paths. New tracking path equals to square bracket. Now iterate through all the good feature points. For TP, x, y, good points, flag in zip, tracking paths, feature points. Reshape, good points. If the flag is not true, then continue. So if not good points flag, then continue. Now append the x and y coordinates and don't exceed the number of frames we are supposed to track and draw a circle around the feature points. So TP append x and y coordinates And here we are using if length tp greater than number of frames to track, so that it don't exceed the number of frames we are supposed to track. And here we are drawing a circle around the feature points to cv2.circle output.image. We are almost end to the code, just hold on a little bit. Now update the tracking paths and draw the lines using the new tracking paths to show the movement. Tracking path, new tracking path, cv2 polylines. And now go into this if condition after skipping the right number of frames. If not frame index, number of frame jumps. And create a mask and draw the circle. Mask equals to np.0 like frame gray. Mask colon equals to 255 for x comma y in np. So here we created the mask and we are drawing the circle, that is cv2.circle mask. Now compute the good feature to track using inbuilt function along the parameter like mask, maximum corner, quality level, minimum distance and block zone. So feature point cv2 equals to feature to track. Here we are computing the good feature to track using the inbuilt function like mask, maximum corners equals to 500, quality level equals to 0.3, minimum distance 7, block size equals to 7. If the feature points exist, then append them to tracking paths. So if feature point is not none, for x, y in np float, feature points reshape -1, true, tracking paths dot append. And then finally update the variables related to frame index and the previous grayscale image. So frame index plus equals to 1, previous gray equals to frame gray. Now display the output, that is cv2 I'm show optical flow output image. Check if the user pressed the escape button, if so exit the loop. So c equals to cv2.wait key 1, if c equals to 27 then break. Then define the main function if name equals to main and start tracking. Once you stop the tracker, make sure that all the windows are closed properly. So cv2 destroy all windows. So this is a code, there is no other way for me to explain it. This is a bit lengthy, just see the code and try to analyze it by yourself or rewatch the video again. So this is how it is. Let's see the output again. Let's run the script. If you run the code, you'll see a window showing the live video. You'll see feature points. If you move around your hand, you will see lines showing the movement of feature points. If you move it in the opposite direction, the lines will also change their direction accordingly. We show the motion of these feature points between successive frames. These vectors are known as motion vectors. There are many different ways to perform optical flow. So that's it. Pretty much long video on optical flow based tracking. I hope you got some points. Here what you have to understand is codes. So that's it in this video on optical flow based tracking. Thank you for watching this video.